Hi everyone, in this video we are going to go through populations and samples, which is 17A. Basically in this section summary, we're just looking at a few definitions. So the main difference between population and sample is population refers to everyone who has a certain trait or members of a group. So if you wanted to look at Collingwood supporters, there would be quite a lot of them, or if we wanted to look at people who were above 60, that would be a lot of people. So what we tend to do, instead of working with a population with statistics, we tend to just take a sample. And if the sample is big enough, then we can apply our findings to the whole population. So that's how statistics work. So just reading these definitions, a population is a set of all eligible members of a group, and a sample is a subset of that group. And generalizing from the sample to the population will not be useful unless the sample is representative of the population. So if we wanted to know, where retired individuals like to travel, so overseas or domestic, so international or domestic, you wouldn't go interviewing people who were under 60, okay, because they're not the same as the population. The third dot point, a sample size n is called a simple random sample if it is selected from the population in such a way that every subset of size n has an equal chance of being chosen as the sample. So in particular, every member of the population must have an equal chance of being included in the sample. So you can have choose people at random. That means you're not going to skew your data in any way. The population proportion, which you will see is denoted by P, and let me just find my pen. Where did I put my pen? There it is. Okay, so let me just get my highlighter. I think I'd be organized, wouldn't you? Okay, so P is the proportion of individuals in the entire population possessing a particular attribute and is constant. And then P with a little hat is the sample proportion. So you've probably come across now exam questions with the P with a little hat. That just means the sample proportion. So is the proportion of individuals in a particular sample possessing the attribute and varies from sample to sample. The sample proportions are the values of a random variable P. Okay, so little p and big P. Now in 17A, it does go through random sampling, so how to do that on your calculator, but you don't need to do that for your exams, because how do they know whether you've chosen people at random or not? Okay, if that makes sense. Because you can just say, oh, I'll just take this one, this one, this one, this one. That's not really random. If you were to do your own statistical analysis, you would actually have to have some, quality process involved, and you can do that on your calculator. All right, so let's have a look at a few questions. So in a certain school, actually, sorry, before we do that, I think I might watch a example. Sorry, I forgot. All right, so this is probably more if we were doing this in our SAC, but I just want to go through what it means by generating a random sample. So we've got a class of students. Okay, so you can see them all listed there. You can use a random number generator, so you won't be examined on this. But what you would need to do is, because calculators work with numbers, not names like Denise and Sharon, I feel like we're in the 80s. You just assign a number and then you use your random number generator to come up with those people. So if we wanted 6 random numbers, we've got 4, 19, 9, 2, 13 and 14. And then you just go, well, what numbers are corresponding to those people? So we've got Sue, Georgia, Miller, Matt, Tom and David. All right. So I'm just scrolling down. Now in example 3, what we're going to do this time is we're going to select 6 people, but determine the proportion of females. So it actually hasn't told us whether they're male or female. So I guess we're just going to go by their name. So we're going to generate another 6 random integers. So we've got 19, 3, 11, blah, blah, blah. Okay, so we've got Georgia, Teresa, Anne, Miller, Sally, and Denise. Now, you know, we're going to be assuming that Georgia, Teresa, Anne, Sally, and Denise are all females, and Miller is male. So for this sample, we have 5 females out of a sample size of 6. Okay, so your sample population, not your sample population, what does p hat refer to again? Sorry. Where are we? Yeah, yes. Oh, your sample proportion, sorry. So your sample proportion is 5/6. So since your sample proportion varies according to the contents of the random samples, we can consider the sample proportions as being the values of a random variable, which we will denote by capital P hat. We investigate this idea further in the next section. All right, so let's go back to the questions. So in a certain school, 35% of the students travel on the school bus. A group of 100 students were selected in a random sample and 42 of them travel on the school bus. Okay, so let's just highlight that important information. So we've got 35% are on the school bus. 100 students were selected in a random sample. So 100 were taken from a random sample and 42 of them travel on the school bus. All right, so when we're doing what is the population, we're not actually calculating how many kids are at the school. So we're looking at all the students at the school. Okay, so all students. What is the value of the population proportion P? So P is the proportion of students who travel on the bus, so 35%, or we can just convert that to a decimal, 0.35. What is the value of the sample proportion? So this is the sample of the 100 students. So that's going to be 42 over 100, which is quite easy to do without a calculator, which is 0.42. All right, so we've got the proportion of students, the population proportion is 0.35, and the sample proportion is 0.42. All right, question 13. Of a random sample of 100 homes, 22 were found to have central heating. So it's nice that they're giving us 100 because that's easy to work out a percentage. 22 were found to have central heating. What proportion of these homes have central heating? Okay, so we are looking at a random sample. So we're going to have P hat. All right, so the sample proportion, because we're not looking at all houses. Okay, we're only looking at 100 homes. So it's going to be 22 out of 100, which is 0.22. And then question B is the value of the population proportion P. Is this the value of the population proportion P or the sample proportion? Now, because we're looking at a sample, it is the sample proportion. All right, so that was quite a quick video. Let's go on to 17B, all right, which I guess will be a little bit longer. All right, so in 17A, I think it was just looking at the definitions between sample and population. You do not need to be doing random sampling. Okay, mainly just knowing the difference between sample proportion and population proportion. Okay, so the exact distribution of the sample proportion. A bag contains 6 blue balls and 4 red balls. If we take a random sample of size 4, what? Okay, I was thinking of the ball size was size 4. Okay, so if we take 4 balls, what is the probability that there is 1 ball in the sample? Okay, so a bag contains 6 blue balls and 4 red balls. Now, in total, there's 10 balls, but we're taking a sample of 4. All All right, so think of those balls in a bag and we're taking out 4. So what is the probability that there is one blue ball in that sample? So basically we want the sample proportion to equal 1/4. All right, so go through the 2 methods. All right, so these methods are here, but I am also going to just play the video on the from the textbook.
This question here is introducing the concept of p hat, which is the proportion of the sample that we want to have a particular characteristic. So we want, of the 4 balls that we choose, one of them to be blue. So therefore p hat is 1/4. So just as a diagram here, I've drawn our bag with 6 blue balls and 4 red balls in it. We've got a sample size of 4, so we're taking 4 of them out, and we want the probability of only one of them being blue. So just to spell this out, what that means is we could have 3 red and then a blue, or 2 red then a blue then a red, or a red, a blue, then 2 reds, or the first one being blue and the rest of them being red. Now, because we're taking them out without replacing them, what we need to do is work out each of these probabilities manually. So the first one here, to select a red ball, there's 4 to choose from and 10 in the bag. So the probability that the first one is red is 4/10. The probability that the second one is red means that there's only 9 left in the bag to choose from because 1 ball has already come out, and there's only 3 red balls now to choose from. Then for the third one to be red, there are now only 8 balls in the bag to choose from, and 2 of them are red. Finally, for the last one, there are 7 balls left in the bag, but there are 6 blue ones to choose from. This accounts for our first combination in the series. For the second one, again, the probability that the first one is red is 4 out of 10. The probability that the second one is red is 3 out of 9. The probability that the third one is blue is 6 out of 8. And the probability that the last one is red is 2 out of 7. In the same way, I worked out the third combination and the last combination. When we work that one through, we get an answer of 4 out of 35. Another way that you could do this question is using combinations, where the probability of getting 1 blue ball out of the bag, having selected 4, would be the number of ways of selecting 1 blue ball out of the total number of ways that we could select 4 balls. So the number of ways of selecting 1 blue ball means of the 6 balls, we want to choose 1 of them only, and of the 4 red balls that are in the bag, we want to choose 3 of them. So that's how we get 1 blue ball out of a selection of 4. Then to get the number of ways of selecting any 4 balls in any combination would be, of the total 10 balls that are in the bag, we want to choose only 4 of them. So of the 6 blue balls to choose 1, that's 6 choose 1. And of the 4 red balls to choose 3, that would be 4 choose 3. And then out of the 10 balls, we want to choose any 4 of them, that would be 10 choose 4. If we work that one through, again, we'll get an answer of 4 out of 35.
All right, head back to our notes. So you can see all the working out there, but sometimes it's easier for it to be explained to you. So you can see how combinations work, okay? But also, you can choose which method works better for you. So sometimes I do find it actually easier to write out the possibilities. This one is probably too big to draw a tree diagram, especially in an exam situation. But if you could kind of picture the tree diagram in your head, you could easily get these probabilities out. All right. So the following table gives the probability of obtaining each possible sample proportion when selecting a random sample of size 4 from the bag. So number of blue balls in the sample, we can have 0, 1, 2, 3, or 4. So you can have no blue balls, 1 blue ball, 2 blue balls, 3 blue balls, 4 blue balls. So the proportion of blue balls in the sample, okay, is 0 out of 4, which is 0, 1 out of 4, 2 out of 4, which is a half, 3 out of 4, or 4 out of 4, which is 1. And then you've got their respective probabilities. So we can see from the table that we can consider the sample proportion as a random variable, capital P hat, and we can write these different probabilities. Okay, so capital P okay, is working with the probability. Sorry, not the probability. It's a random variable, and you can write it like this. Okay, so instead of using, in the past we've used x, so x equals 0, we've got p hat equals 0 or p hat equals 1 out of 4 because we're looking at the sample proportion. And which one did we do? 24 out of 210, which we know is what we did in the previous question. All right, the possible values of p hat and their associated probabilities together from a probability distribution for the random variable p, which can be summarized as follows. Okay, so we've got just a table summarizing the probabilities and the sample proportion. Okay, so the probability of getting 0 out of 4 is 1 over 210, 1 out of 4, 24 over 210. They haven't simplified it, but you can see there they're all over 210, which makes it a bit easier to compare. The distribution of a statistics which is calculated from a sample, such as the sample proportion, has a special name. It is called a sampling distribution. Okay, so what we've got in this table is just a sampling distribution. All your probabilities have to add up to 1. Okay, so if we added these up, we would see we get 210 over 210, which is 1. All right, if we are selecting a random sample of size n from a large population, okay, so n is n is the number of people you're choosing from the population, then the mean and standard deviation of the sample proportion are given by. Okay, so what we have here is your mean. Whoops, let me just get my pen. All right, so remember this is your mean. So in the past we've used the expected value of x. This is the expected value of your sample proportion, and this is your standard deviation. Okay, so similar formulas as before, but you're used to seeing x, but now we're using p. The standard deviation of a sample statistic is called the standard error. All right, so that's important to note. So the standard error. All right, so let's work through some questions. I wonder how many questions I've got. Oh, quite a few questions for this one. Cool. All right, so question 1, consider a bag containing 5 blue and 5 red balls. Okay, so 5 blue and 5 red balls. Now remember in the example, she drew them. So if we want to draw them, we can. So we've got 1, 2, 3, 4, 5. And red, I'll just do as pink. 1, 2, 3, 4, 5. All right, so there's our balls. What is P, the proportion of blue balls in the bag? Okay, so we're not doing the sample proportion, we're doing the population proportion. So it's just going to be P. Blue balls, there's 5 out of a total of 10. So it's going to be half. Or if you wanted to write that as a decimal, don't have to though. All right, question B. If samples of size 3 are taken from the bag without replacement, then a sample could contain 0, 1, 2, or 3 blue balls. What are the possible values of the sample proportion P of blue balls associated with each of these samples? All right, so let's do a distribution. So that's question C. So I might do B and C together. So P can be 0 out of 3, 1 out of 3, 2 out of 3, or 3 out of 3. Okay, so our sample is 3, and we can have 0 blue balls, 1 blue ball, 2 blue balls, or 3 blue balls. So with question C, we're going to do a probability distribution. All right, so let's just do P hat. Okay, so we've got 0 1 out of 3, 2 out of 3, and 3 over 3 is 1. Oh God, that's a big one. I'll just make it a bit smaller. All right, so let's just draw our table. All right, so when you're looking at your probability, remember back to the example we went through. You can either do all your different possibilities, which can be quite time consuming, or you can consider using combinations. All right, obviously, if you're using combinations, you need to use your calculator. All right, so we're going to stick with combinations just because we haven't really done a lot using combinations. All right, sorry, I had a glitch. So let's just quickly go through this example to help us with question 1. So remember, we need to work out the total of ways of selecting. So in this example, we're selecting 4 balls from 10, but in question 1, we're selecting 3 balls from 10. So we're going to be doing 10, choose 3. And then we'd work out how many ways there are to choose 5, well, depending on which one we're doing. So if we want 0 balls, it'll be 5, choose 0. If we want 1, 5, choose 1, and so forth. So let's go. Why is nothing working? Okay. So for question C, I'll just do it on the side here. So the probability that P equals 0 is we're going to have 5, choose 0 for, what colour did we want? Blue. So let's do that in blue, and then I'll do red in pink. So if we've got 0 blue, then we've got 3 red, and we're going to divide that by how many combinations there are in total. So we've got 10 balls, and we're choosing 3 balls in total. All right, so I'll do that on the calculator in a sec. Then we do the same for 1. So we've got 5, choose 1. But this time, because we've already chosen 1 ball, we only need 1 blue ball, we only need 2 red balls. And that's still over 10, choose 3. And then going to have, not 1, sorry, 1 over 3, 2 over 3. And that should be a little p, sorry. So 5, 2 times, and this time we're going to have 5, choose 1. Over 10, choose 3. And then lastly, we're going to have 1. So 5, choose 3. And then 5, choose 0. Now you'll notice because we've got the same number of blue balls as we do red balls, your answer for 0 and 1 are going to be the same, and 1/3 and 2/3 is also going to be the same because we've got the same calculation. So effectively we only need to do 2 of them. Let's get my calculator up. All right, so your combinations, just go to main and bring your keyboard up, go down to advanced, and then we want NCR. So we put the first number, so we want, let's just go over here. We're going to be doing 5, choose 0 times 5, choose 3. So I'm just going to do it separately. So that's 1. I'm just going to highlight it and drag it down. Don't need to. You can redo it. And then we want 10, choose 3. So effectively, I'm going to have 1 times 10 over 120. and that's going to be the same for 1 because we've got the same number of blue balls as we do red balls. All right, so that is equal to 10 on 120, which is the same as 1/12, and this is going to be also 1/12. All right, now in the middle, we're going to have, you can drag it down again, 5 choose 1, and 5 choose 2. And we've already done 10 choose 3, which is 120. So we're going to have 5 times 10 over 120 and 5 times 10 over 120 because they're the same calculations. All right, so 50 over 120, so it's just going to be 5 over 12. And that's also going to be 5 over 12. All right, so question D, use the sampling distribution from C to determine the probability that the proportion of blue balls in the sample is more than 0.5. That is, find the probability that P is greater than 0.5. Okay. All right, so in our distribution, we need to work out where 0.5 is. So 0.5 is actually between 1/3 and 2/3, so it's around here. So we want to be greater than 1/2, so we're going to be just including these two values here. So their probabilities are 5 over 12 and 1 over 12. So that gives you 6 over 12, which we can just simplify to 1/2. So very similar to what we would do when we were working with discrete random variables and the distribution table. Yeah, so just working out greater than 0.5. If you wanted less than, then it would be the other direction. So just finding out where 0.5 is on that table. All right, moving on to question 4. So a random sample of 3 items is selected from a batch of 10, which contains 4 defectives. Okay, so we've got a random sample of 3 items is selected from a batch of 10 items, which contains 4 defectives. So what is P, the proportion of defectives in the batch? So I'm just going to write A down here. Okay, so P is the number of defectives is 4, so it's going to be 4 out of 10. Okay, so we've got a batch of 10, so that's going to be 0.4. You could leave it as 4 over 10, it's fine. What are the possible values of the sample proportion of defectives in the sample? So we can have, what can we have? 0, 1, 2, 3, or 4. Actually, no, we're only getting a sample of 3. So we can have 0, 1 out of 3, 2 out of 3, or 3 out of 3. All right, so question C, construct a probability distribution table. So very similar to what we did before. All right, so we can have 0, 1 over 3, 2 over 3, or 1. And we need to work out the probabilities. Okay, so just similar to what we did before, I might do it over here. So the probability that P is equal to 0. So our total is easy to work out. So we've got 10 and we're choosing 3 items. Oh, is this going to be exactly the same as before? No, because we've got a different number of items. Okay, so how many have we got defective? So 4 defective. And we're choosing 0. So that means we've got 6 that aren't defective, and that means all of them that we're choosing. So 3. So remember, we're choosing 3 items. So the first, I should put a times in here. This one here is the defective. and this is not defective. So it got 0 defective. So remember, we're taking a sample of 3. So that means 3 have to be not defective. All right, let's do 1/3. So this time we're choosing, oops, no, I did that right, sorry. 1 defective and 2 not defective out of 10/3. And you get the gist. Now, this isn't going to be symmetrical because we've got different number of defective and not defective. So we are going to have to do all of them. 4, 2, 6, 1. I've given myself enough room. Oh, I've given myself heaps of room. All right, and then so 4, choose 3 times 6, choose 0. So this means all 3 are defective. All right, and you can just do that on your calculator. All right, just like we did before, but I'm not going to spend time doing that on the calculator, so I'll just pause to write down the answers. All right, for question D, let me just scroll up so we can see it. Use the sampling distribution from C to determine the probability that the proportion of defectives in the sample is more than 0.5. So we want the probability that P is greater than 0.5. So we're going to be looking at these values here because they're greater than 0.5. So 3/10 plus 1/30. Now to do that, you will need the same denominators or a calculator. I'm just going to quickly do it. Yeah, so 9, 10, 10/30, which is 1/3. Good. All right, and E, sorry, I feel like I'm working quickly, but we did that in the previous question. This time we're looking at between 0 and, so P is greater than 0, but less than 0.5. And hence find, oh, we've got conditional probability, and I probably haven't given myself enough space. All right, so if we're doing between 0 and 0.5, all right, so I'll just write that down. Okay, so let's look at the values between 0 and 0.5. So the only one is 1/3, so this one here. So that's going to equal 1/2. Now, what we have in the second part of the question is conditional probability. So the probability that P is less than 0.5, and that P is greater than 0, is equal to what they have in common. So what we have just done is what they have in common. So the probability that P is between 0 and 0.5 over the probability that's greater than 0. All right. So in the previous question, we worked that out to, well, not question, but the first part, we worked that out to be 1/2 for the numerator divided by P is greater than 0. So we can do 1 minus P equals 0. So that's going to be 5/6. Now, that's the same as 1/2 times its reciprocal. So we're going to have 6/10, which is 3/5. So a bit squishy there, but yeah, 3/5 for that conditional probability. All right, moving on to question 11. Oh, 11, 12, 13, 14. All right, maybe we won't do all of them just because I don't want this video to be too long. Suppose that the probability of a rain on any day is 0.3. Find the, oh, so now we're doing mean and standard deviation. So the mean and standard deviation of the sample proportion of rainy days which might be observed in the month of June. So suppose that the probability of rain on any day is 0.3. Find the mean and the standard deviation of the sample proportion of rainy days which might be observed in the month of June. All right, so for question 11, now we're looking at the probability that it's going to rain in June. So how many days are there in June? There are 30. And the probability it's going to rain, so the probability of success is 0.3. So we want to find the mean and the standard deviation of the sample proportion. Okay, so I'm going to scroll back up here so we can see the notation we're using. So remember, the expected value, or our mean, is equal to P. So in this case, it's 0.3. And then to work out the standard deviation, we're just going to do P times Q. So our probability of failure is 1 minus P over N. So the square root of PQ on N. Scroll down. So remember, Q is the probability of failure, which is just 1 minus P. So in this case, it's 0.7. All right, so our expected value is just equal to P, which is 0.3. And our standard deviation is equal to the square root of P times Q over N. So we're going to have 0.3 times 0.7 over N, which is 30. And we're going to have to take the square root of that. So we need to do that on the calculator. I was trying to simplify it, but we'll just do it on the calculator. All right, let's go back to our calculator. So 0.3 times 0.7 over 30. Now we're in standard, so I'll just put it in decimals. So 0.0837. Okay, so we've got our expected value here and our standard deviation here. All right, for question 12 and 13, let's just talk them through, but you use the same formulas. Okay, so in certain country, it's known that 40% of people speak more than one language. If a sample of 100 people is selected, find the mean and standard deviation of the sample proportion who speak more than one language. So it's just our variable, more than one language. We're not doing greater than or equal to 1. All right, so I'm going to highlight, not highlight that. Okay, so for question 12, our value of N is our sample, so 100. And P, our probability of success, is 0.4. So that makes Q equal to 0.6. And we didn't need to do anything else. Okay, so your mean is going to be 0.4, and then you just use the formula for standard deviation. Question 13. An examination consists of 100 questions, each with 5 possible answers. Well, it sounds like you're sacked, doesn't it? Find the mean and standard deviation of the sample proportion. Correct answers will be achieved if the student guesses any answer. So for question 13, I might just do it over here. N is equal to 100. P, so 1 out of 5. So that means Q is 4 out of 5. So we do know if they guess it that you would get 20% correct, so 1 in 5. And then your standard deviation, you would just use the formula for that. All right, let's move on to question 14. So suppose that 65% of people in Australia support an AFL team. If a random sample size 20 is chosen from this population, find the probability that the sample proportion is equal to the population proportion. Now, before we do this question, because it's similar to one of the examples, I'm going to take you to the example and play you through it.
The This question here is dealing with a sample of
17-year-olds, and we're looking at whether these 17-year-olds attend school or not. Now, for this particular problem, we're going to assume that 70% of all 17-year-olds attend school in Australia. So the first question asks us to find the probability that the sample proportion, i.e. p hat, is equal to the population proportion. So we're wanting to know that in our sample of 20 that we choose, what is the probability that 70% of them attend school? So what is the probability that p hat is equal to 0.7? So we want to know, of the 20 students that we sample, what is the probability that 14 of them attend school, 14 being 70% of 20. So to work that out, we're going to go back to our binomial distribution. We're looking at a sample size of 20 and we want 14 successes, so 14 students in school. The probability of success, that is the chance that they are in school, is 0.7 to the power of 14, times by the probability of failure, being the chance that they are not in school, to the power of 6. When we work that one through, we get an answer of 0.1916. For part B, it's asked us for the probability that the sample proportion, that is p hat, lies within one standard deviation of the population proportion. So what we're saying is, what's the chance that the sample proportion is the population proportion minus one standard deviation and the population proportion plus one standard deviation? Just as a side note, to work out what the standard deviation is for our sample, we use this formula here. So when I replace p with 0.7 and n with 20, I end up with an answer of 0.1025. So back to the question, what we're looking for is, in our sample of 20, we want the probability that between 59.75% and 80.25% of them attend school. To work out what that is in number of students, that's 59.75% of my sample. So that's 0.5975 times my sample size. And this one here, if I want to know what 80.25% is of my sample, that would be 0.8025 multiplied by 20. So you notice that I've changed p hat into x because I'm now talking about the number of students in the sample. So this is the number of students in the sample that we are wanting to attend school. Except we're talking about number of students. So I've just shown that as a number line over here. We need to be between 11.95 and 16.05. So the nearest whole numbers that are within that range are 12 and 16. To evaluate that probability, we need to go to binomial CDF. We set the number of students to be 20, the probability of success to be 0.7. The lower bound is 12 and upper bound is 16, and that will generate a result of 0.7796. Part C is very similar, but this time we're looking for the sample proportion to be within two standard deviations of the population proportion. So that is p minus 2 standard deviations and p plus 2 standard deviations. So we're looking at 70% minus 2 lots of 0.1025, and 70% plus 2 times 0.1025. So in this case, what the question is really asking us for is, what is the probability that the proportion of students in our sample is greater than 49.5 but less than 90.5%. The next step is to turn that proportion into a value which represents the number of students. So 49.5% of 20, the 20 in our sample, and 90.5% of our sample works out to be numbers that are greater than 9.9 and less than 18.1. So we want 10 or more of them to be attending school, up to and including 18 of our sample to be attending school. Again, we go to our binomial distribution to work this one out. We set the sample size as 20, the probability of success as being 0.7, lower bound 10 and upper bound of 18, and we get an answer of 0.9752.
All right, so let's go back to question 14. So this time, very similar question. Let me just find my pen. Okay, so for question A, we want to find out the probability that the sample proportion is equal to the population proportion. So we know that 65% of people in Australia, so that's our population proportion. So we want our sample proportion to equal 0.65. Okay, so we can use, as you saw in the video, that we can use the binomial distribution. Just remember that we're looking at different P's. Okay, so P is your probability of success, but can also be your population proportion. So don't get them mixed up. So our sample size is 20. Our probability of success is 0.65. And probability of failure is 0.35. So we want to, sorry, I just realized what we have to find X as well. So how many we want. So we want 65% of 20. So 65% of 20 is 13. Okay, so we're going to have 20 choose 13. All right, so just using the binomial distribution, probability of success is 0.65, choose 13, and then we're multiplying it by 0.35. It's going to be 7. Okay, so I'm going to just do that on the calculator. No, actually, you could do that using your binomial. All right, you can't see my calculator. There we go. So X is 13, number of trials is 20, and the probability of success is 0.65. Okay, so we get 0.1844. All right, so for question B, the probability that the sample proportion lies within 1 standard deviation of the population proportion. So we need to find the standard deviation first. All right, so remember that's the square root of P times Q over N. So P is 0.65, Q is 0.35, and N is 20. I'm taking the square root of that, don't forget that. Remember in the video, she didn't refer to Q, but Q is 1 minus P, the probability of failure. So they are the same thing. Let me just get my calculator up. All right, so the square root of 0.65 times 0.35 over 20. So we got 10,665. Was it 655? 665. All right, so that's our standard deviation. So if we're looking at 1 standard deviation either side, all right, so we're going to be, what are we going to, P minus 1 standard deviation. And P plus 1 standard deviation. All right, so just put the values in. So P is 0.65 minus 1 standard deviation. P plus, whoops, no, I did that right, sorry. So many numbers. P is 0.65 plus 0.10665. And I'm going to put the probability at the start. Okay, so we can do that on the calculator. And the good thing is we can just drag and drop it down. I wish the calculator would just stay there. 543. And same thing, we're just going to put a plus in the middle now. So 75665. Doesn't really matter how many decimal places you're doing, because remember, we've got to think of the context of the question, and we're actually looking at people, so we do need to convert them into integers. So we're looking at a proportion, so a sample proportion, 0.543. So we just multiply that by our population. So we're going to multiply that by 20 and multiply this by 20 to get the number of people. So remember, in the video we change it from our sample proportion, p hat, to x. So let me just do that on the calculator. So I'm going to take this value and multiply it by 20. So we've got 10.9. And then the other one, $15.1. So we want to go from, want to be greater than 10.9, so it's going to be 11, and less than 15. All right, so we can just now do it's a binomial. So n is going to be 20. P is still 0.65. Your lower bound is 11, and your upper is 15. So we can just do that on the calculator. So this time we're going to CDF, binomial CDF. Your lower limit is 11, your upper limit is 15, number of trials is 20, and the probability of success is 0.65. So 0.76. All right, for part C, I'm assuming we're doing 2 standard deviations. Yep, we are. So let's just go down. Now, we've done a lot of the calculations already, so I'm just going to write the notation. So we want to be between 2 standard deviations below. And 2 standard deviations above. So I can just do that on my calculator. I think I just forgot a bracket. Put it on the end there. Okay, so back on here, we've got standard deviation. If I just go back up here, there it is. All right, so I'm going to highlight that, copy that down. All right, so P is still 0.65. And then we're going to be subtracting 2 times our standard deviation. So I'm just going to paste that in. So 0.437. And now 2 standard deviations above. So I can just highlight that and just put the plus in. Excuse me. Hello. Thank you. All right, 0.863. Now we convert them into, so at the moment they're proportions, so we're actually going to work with integer values. Oh gosh, I don't know whether you can hear that rain, it is pouring now. All right, so we've got 8.7. And sorry, I'm rushing. I just feel like very similar to the example we did. All right, 17.3. All right, so effectively we're looking at the probability between, has to be greater than 8.7, so the nearest integer is 9. Oops, and this time we're changing it to x, sorry, forgot that. And 17.3, we want a value less than that, so it's 7. So we're going to be using binomial CDF again. So same number of trials, probability of success is the same. This time our lower limit is 9 and our upper limit is 17. All right, so with your calculator, you can just copy what you had before. All right, we're just changing our upper and our lower limit. So our lower limit is 9, and what was our upper limit? 17. Cool. So 0.9683. All right, so that was 2 standard deviations. So make sure you understand those questions, girls. We can do them on the calculator. You wouldn't expect to do them without your calculator, but perfect exam 2 question. All right, bye.